Good day, everyone. We are the Group 4, and today we will talk about our topic entitled Chapter 4, Non-Parametric and Chi-Square Test. But before that, here is an introduction of our group. I am Magallanes Aliah Jean, and I am the leader of this group. My group members are Aguilar Andrea Rose, Boy Melgrace, Condez Sophia Louise, and Degabi Lylene. Now that we have introduced ourselves, let's go ahead with the discussion.
Non-parametric. Non-parametric tests are the mathematical method used in statistical hypothesis testing, which does not make assumptions about the frequency distribution of variables that are to be evaluated. The non-parametric experiment is used when there are skewed data, and it comprises techniques that do not depend on data pertaining to any particular distribution.
Chi-square test. Pearson chi-square test is a statistical test for categorical data. It is used to determine whether your data are significantly different from what you expected. It is often used to analyze data that is presented in a contingency table, which is a table that displays the frequency distribution of two or more variables. The chi-square test is widely used in many fields, including social sciences, business, medicine, and engineering.
Types of chi-square tests. There are two commonly used chi-square tests, the chi-square goodness of fit test and the chi-square test for independence. Both tests involve variables that divide your data into categories. So let us know first the chi-square goodness of fit test. The chi-square goodness of fit test is a single sample non-parametric test, also referred to as the one sample goodness of fit test or Pearson's chi-square goodness of fit test. It is used to determine whether the distribution of cases, for example participants in a single categorical variable such as gender, consisting of two groups, males or females, follow a known or hypothesized distribution like a distribution that is known, such as the proportion of males and females in a country, or a distribution that is hypothesized, such as the proportion of males versus females that we anticipate voting for a particular political party in the next elections.
Here are the assumptions. Number 1. One categorical variable that is the variable can be dichotomous, nominal, or ordinal. Number 2. You should have independence of observations, which means that there is no relationship between any of the cases. For example, participants. And for the number 3, there must be at least 5 expected frequencies in each group of your categorical variable. In this type of hypothesis test, determine whether the data fit a particular distribution or not. And the test statistic for a goodness of fit test is x squared is equal to the summation of O minus E squared divided by D, where O is observed values or the data, E is the expected values U, and K is the number of different data cells or categories. The number of degrees of freedom is DF is equal to the number of categories minus 1.
Here is the procedure for the chi-square goodness of fit test. Step 1. State the null and alternative hypothesis. Step 2. Level of significance. Step 3. Indicate the type of test. Find the critical value from the chi-square table. You can refer to the appendix. Remember that the test is always right-tailed. And state the decision rule. Step 4. Compute the test value. And step 5. Make a decision.
Example problem of chi-square goodness of fit test. Aliah's group wishes to find out the preference of drafting students among the 5 drafting tools: T-square, technical pen, mechanical pen, triangular scale, and triangles, commonly used in making architectural drawings. A random sample of 150 drafting students is selected, and the following data are obtained. At a 0.05 level of significance, can it be concluded that there is no preference in the selection of drafting tools? So, here is the preference table of drafting students among 5 drafting tools. For the T-square, has a frequency of 57, technical pen 21, mechanical pen 24, triangular scale 12, and triangles 36.
This is the solution for the example of chi-square goodness of fit test. Step 1. State the null and alternative hypothesis. For the null hypothesis, there is no preference in the selection of drafting tools. And for the alternative hypothesis, there is a preference in the selection of drafting tools. Then for the step 2, the level of significance is 0.05. For step 3, the statistical test used in chi-square goodness of fit, and for the critical value, the degree of freedom, 5 minus 1 is equals to 4. As you can see in the chi-square table, the label of significance is 0.05 and the degree of freedom is 4, so that the critical value is 9.488 or 9.49. Then, the decision rule, reject HO if the test value is greater than or equal to 9.49, otherwise do not reject HO.
And for the step 4, compute the test value. Note, the expected values are found by E is equals to N divided by K, where N is the total number of drafting students, and K is the number of different data cells or categories. Therefore, 150 divided by 5 is equals to 30. In the table, the observed column is the frequency of drafting students among 5 drafting tools, and the total number of selected drafting students is 150. In the third column, the expected values are all 30. And the fourth column, subtract the observed and expected. For the T-square, 57 minus 30 is equals to 27. Technical pen, 21 minus 30 is equals to negative 9. Mechanical pen, 24 minus 30 is equals to negative 6. Triangular scale, 12 minus 30 is equals to negative 18. Triangles, 36 minus 30 is equals to 6. For the fifth column, square the subtracted value of observed and expected. For the T-square, 27 squared is equals to 729. Technical pen, negative 9 squared is equals to 81. Mechanical pen, negative 6 squared is equals to 36. Triangular scale, negative 18 squared is equals to 324. Triangles, 6 squared is equals to 36. And for the last column, divide the squared value by expected. For the T-square, the value is 24.3. Technical pen, 2.7. Mechanical pen, 1.2. Triangular scale, 10.8. Triangles, 1.2. And then, add all the values of the last column so that the expected frequency is 40.2. And for the last step, the step 5, make a decision. The critical value is 9.49 and the chi-square test value is 40.2. So that reject HO since 40.2 is greater than 9.49. Therefore, there is a preference in the selection of drafting tools at 0.05 level.
Chi-square test for independence. The chi-square test of independence is used to determine if there is a significant relationship between two nominal categorical variables. The frequency of each category for one nominal variable is compared across the categories of the second nominal variable.
So when you choose to analyze your data using a chi-square test, you need to make sure that the data you want to analyze passes two assumptions. These two assumptions are, number one, the two variables should be measured at an ordinal or nominal level. Assumption 2, the two variables should consist of two or more categorical independent groups.
For the procedure of chi-square test for independence, Step 1, state the null and alternative hypothesis. Step 2, level of significance. Step 3, indicate the type of test, find the critical value from the chi-square table, the test is always right-tailed, and state the decision rule. Step 4, compute the test value. And last step, Step 5, make a decision.
Here is the example problem for the chi-square test for independence. Aliah and her group wish to determine whether there is a difference in the type of drawing papers selected by males and females for architectural drafting plates. A random sample provides the data given here. At 0.05 level, test the claim that the type of drawing paper selected is independent of the gender of the individual.
This is a random sample table of male and female choosing of what type of drawing papers. For the bond paper, male has 28 and female has 26. And for the vellum board, male has 41 and female has 49. And last, for the tracing paper, male has 72 and female has 84. This is the solution for the sample problem of chi-square of independence. Step 1. State the null and alternative hypothesis. For the null hypothesis, the type of drawing paper selected is independent of the gender of the individual. And for the alternative hypothesis, the type of drawing paper is not selected is independent of the gender of the individual. Next, for the step 2, the level of significance is 0.05. For step 3, the statistical test used is chi-square of independence. The degree of freedom r-1 times c-1, where r is the total number of rows and c is the total number of columns. Based on the table, there are 2 rows, male and female, and there are 3 columns, bond paper, vellum board, and tracing paper. And to solve for the degree of freedom, r-1 times c-1 is 2 minus 1 times 3 minus 1 is equals to 1 times 2 is equals to 2. So the degree of freedom is 2 and the level of significance is 0.05. As what you can see at chi-square table, the critical value is 5.991 or 5.99. Then the decision rule, reject HO if the test value is greater than 5.99, otherwise do not reject HO.
So now, let us compute the test value. First, let us solve the expected frequency 1, row 1, using the formula below. Our expected frequency 1, row 1 is male. So now, let us distribute. The expected frequency row column is equal to number of rows times the number of column over the total number. So, our first N1, or the number of row, is equal to 141. Next is the number of column, or we can call it as N1 also. It is equals to 54. Now, let us add all the number of row and column. So, the total is 300, which means our expected frequency 1, row 1 is 300. So now let us solve. So the expected frequency 1, row 1 is equals to number 1, which is the number of row, and times to the number of column, which is 54, over the total number. So now let us substitute. 141 times 54 over 300 is equal to, our answer is 25.38.
Step 4. Compute the test value. So in row 1, column 1, 141, which is the row 1 total, multiplied to column 1 total, which is 54, is divided by 300. The overall total of row and column is equals to 25.38. In row 1, column 2, 141 times 90 divided by 300 is equals to 42.3. In row 1, column 3, 141 times 156 divided by 300 is equals to 73.32. So in row 2, column 1, 159 times 54 over 300 is equals to 28.62. In row 2, column 2, 159 times 90 divided by 300 is equals to 47.7. So in row 2, column 3, 159 times 156 divided by 300 is equals to 82.68.
And now, we will proceed with the next formula, which is x squared is equals to the summation of the observed frequency of each row and column minus the expected frequency of each row and column squared over the expected frequency for each row and column. By substitution, we have x squared is equals to 28 minus 25.38 squared over 25.38 plus 41 minus 42.3 squared over 42.3 plus 72 minus 73.32 squared over 73.32 plus 26 minus 28.62 squared over 28.62 plus 49 minus 47.7 squared over 47.7 plus 84 minus 82.68 squared over 82.68, which then gives us x squared is equals to 6.8644 over 25.38 plus 1.69 over 42.3 plus 1.7424 over 73.32 plus 6.8644 over 28.62 plus 1.69 over 47.7 plus 1.7424 over 82.68. Then that gives us x squared is equals to 0.2705 plus 0.0400 plus 0.0238 plus 0.2398 plus 0.0354 plus 0.0211, which then gives us x squared is equals to 0.6306 or 0.63. So now we know that the critical value is 5.991 or 5.99 and the computed test value is 0.63, which then we can now proceed with step 5, which is make a decision. So the decision is do not reject HO since 0.63 is less than 5.99. Thus, the type of drawing paper selected is independent of the gender of the individual at 0.05 level. So this is the end of our presentation. We hope you learned something. Thank you for listening and have a good day.